Hello, this is Mark O'Brien from Scalyr, now part of SentinelOne. I'm going to provide an overview of dashboards, calling out some of the functionality we recently added as part of our new UI. Dashboards are a key component of the Scalyr observability solution. And while Scalyr is focused on ingesting logs and other event data, we're also able to extract metrics from that event data and visualize those metrics. We were able to do this effectively because in addition to our columnar data store, we also have a time series database. Saving a graph to a dashboard and then loading that dashboard is all it takes for a time series to automatically be created. In database terms, what we're doing is creating materialized views of that data. But ultimately, what it means is that dashboards load quickly, allowing you to spot trends and anomalies in your data. To start, let's go to the Dashboards menu and select View All Dashboards. What I'm going to see here is an overview page showing me all the dashboards that are in my account. If there's a summary provided, I can see that here, and I can also see a description of each of the panes on each of the dashboards. I can click on the dashboard name to go and see the dashboard, or if I click on one of these graphs, I can go directly to that graph itself. I'm going to go ahead and open the web traffic dashboard here. What you'll notice is there's a default time frame at the top, and I can change the time frame by selecting one of the preset values, or just like with the search interface, I can also enter a certain time frame if I want to go back further in time. So I have a lot of flexibility in terms of the time frame viewing my data. On some dashboards, you'll notice there's a parameter menu. In this particular demo, I've got a few different types of servers. I've got app servers, image servers, and web servers. By default, I'm looking at all of my servers, but I can also just narrow down, for example, to my apps. This is a great way to have the same view, but slice and dice your data in different ways. We'll talk more about this in a later video about how to set up a parameter menu. I'm now going to show you how to build each of the panes on this dashboard. The easiest way to build a dashboard is to start with search. What I've got here is a search for request equals star. And what that's going to do is return all results where the request field has some value in it. Because this sample account has a number of different data sources in it, this is going to allow me just to focus on the web traffic that I'm interested in. I can click on the expand graph button, and what you'll see here is I'm getting a graph of the matching events per second. So this is showing me the contour of the number of log lines coming in over the last 12 hours. I'm going to go ahead and save this to a dashboard. And I'm going to create a new dashboard called Web Traffic. You'll notice I also have a number of facets here. The time MS facet is a numeric facet, and because it's numeric, I have the option to graph the values. So what I'm looking at now is a graph of the time MS facet, so it's the value in this facet over time, and I'm using the mean function to represent this. You'll notice there are a number of other functions as well, min, max, sum per second, and also percentiles. I'm going to go ahead and select the 90th and the 99th percentile. So this is going to give me a visual representation of the average response time, but it's also going to show me the outliers as well, so I can get a sense of how, for the folks who are having the worst experience on the website, what their performance is like. I'm going to go ahead and save this to the dashboard as well. And when I go to the dashboard, you'll see now I have two graphs. We have a handy magnifying glass link here. If I click that, it takes me back to the graphs page. And you'll notice with the response time graph, since this is a multiplot graph, it gives me a choice of which of the three plots I'd like to investigate further. Next, I want to talk about breakdown graphs. I have a page facet here that shows me each of the different web pages on my site. And if I go ahead and break down by the page facet, I can see the relative performance of each page. And right out of the gate here, I can see some very interesting stuff. My friends page seems to be getting these spikes every few minutes. The profile and the home page tend to take longer to load on average than the rest of the pages. This is really good. So I'm going to go ahead and add this to the dashboard as well. As I mentioned earlier, saving a graph to a dashboard and then loading that dashboard causes a time series to be created automatically. There is an exception to this with breakdown graphs. The reason for that is that the values in these facets can change over time, so we do not build time series for breakdown graphs. Instead, we render these on the fly. As a result, you may notice that time series graphs take a little bit longer to render, especially over longer time periods. There is a solution for this, however. We can build a multiplot graph that bakes in all of the values of the pages here. And since my page values don't change much over time, this is an acceptable solution for this scenario. I'm going to go ahead and build a graph from the dashboard and show you how that works. So I'm using the mean function on the time ms field. My filter is the same request equals star that I've been using, and I'm limiting to page equals friends, and I'm going to have a label called friends. I'm now building the second and third plots with the same structure, but using different values for the page filter and the label. So now I've got a multiplot graph with 3 plots for my first 3 pages. I could continue doing that through the UI, or let me show you an alternate solution. Behind each graph is JSON. When I flip over to JSON mode, there's some expanded functionality that's available, and it also helps with certain shortcuts, kind of like this one. So I can copy and paste this, and then edit the values. So here I'm going through each of the additional plots and editing the filter and label. So now I've hard-coded each of the page names for the page facet into my multiplot graph. And you'll see that this loads faster than the breakdown graph. In addition to building graphs from search, you can also build graphs from PowerQueries. So I'm going to flip over to the PowerQuery interface here and build a PowerQuery. All PowerQueries start with a filter, so I'm going to be looking at fields which have a value for request and a value for page. So I'm basically searching just for the web page traffic that I'm interested in. I then want to do a group, and I'm going to create 2 columns. One column that's a count of all lines, and one column which is a count of failures, where failures are defined as status equals failure. And I'm going to group these by the page facet. I can then create a new column called failure percent, which is failure divided by count times 100. And I'm going to sort in reverse order on failure percent. When I run this query, you'll see I get a table that lists each of the pages on my website with a count, a number of failures, and the failure percent, with the failure percent sorted in reverse order. I can go ahead and save this to my dashboard. And when I go to this dashboard, you'll see that I have a table that I created. As with breakdown graphs, PowerQueries are not put into the time series database. They're rendered on the fly, and therefore they can be a little bit slower to render, particularly over longer time periods. PowerQueries can also be used to generate other types of visualizations. For example, a pie chart. I'm going to go over to PowerQueries here and generate a Power Query which is going to result in a single text column and a single numeric column. So again, I'm starting with my filter, request equals star and page equals star. Then I'm going to group by page with one column called count. And I'm also going to sort in ascending order by count. So when I run this Power Query again, I have one column for the labels and one column for the values. If I take this Power Query and I go back to the dashboard, I can click on this plus sign, go to pie chart, and paste my filter. And I'm going to give it a name. And now I have a pie chart showing the relative popularity of each page type. We can also use Power Queries to graph a calculated value over time. To do that, I'm going to go back to Power Queries. And with this Power Query, what I'm going to do is I'm going to create a column called error percentage, which is a count of the failures divided by the total count. So this is giving my error rate times 100. And I'm going to group this by a new function called time bucket. What this is going to do is divide up my entire window of time into buckets. When I leave this blank, it's going to use an automatic value. And so in this case, I get 8 values for this time frame. I'm going to go ahead and save it to a dashboard. When I save this to the dashboard, I get a table. But what I can do, I can go into the JSON and add an additional parameter called graph style, which I set to line. And with this change, I'm now graphing this change over time. One thing that's interesting about the time bucket function is that it accepts a few different types of parameters. If I give it just a number, it's going to go ahead and divide the time frame into that number of buckets. So by increasing the number here, I get a more well-defined graph. I'm going to go ahead and round out my dashboard with a few big number graphs. So I'm going to click on the plus, select number, and I'm going to do a requests per second calculation. The way I'm going to do this is grouping by count of the total number of lines divided by another special function called query span expressed in seconds. So as a result, this is going to calculate requests per second over the time frame for this dashboard. And there I have my big number for requests per second. Let's also create a big number display showing our error rate over the entire time period. For this Power Query, I'm grouping by the count of all lines where status equals failure divided by the total count of all lines times 100 to get my error percent. And you'll see here is my error rate in percent. Let me show you one extra feature here I can do by editing the JSON. I'm going to add a parameter for options, and I'm going to specify suffix is percent. When I do that, now my big number renders with a percentage after it. To learn more about options like this and working with new visualizations from Power Queries on dashboards, you can visit our support center at support.scalyr.com and then navigate to New Scalyr UI Dashboard Introduction. This document covers each of the new visualization types along with the options available to them. I'll post a link to this in the comments as well. I'm now going to take advantage of the flexible layout to resize and move some components around to clean up the display a little bit. I want to show you one more feature here. We also have the ability to view in full screen mode. This is great if you want to put a dashboard up on a wall mount or just have it up on a screen so it's always visible. When we enable full screen, we now have the option to refresh at a given interval so that the dashboard will continuously be updated and you can spot any trends as they happen. I hope you found this overview useful. For more information, you can check out the help pages within the Scalyr product. You can also go to support.scalyr.com to check out our help center, which has a number of useful knowledge base articles, as well as the ability to open a ticket for our support team. Thank you very much.